In this demonstration, we're going to walk through how Geoweaver makes complex workflows simple and how it can be used at every stage of a project, from prototyping to production. We will be assembling a complex national weather prediction workflow using Geoweaver, and then showing how it can be pushed to a website or app. All the necessary processes have been created in advance of the demo, so let's dive into how they can be put together using Geoweaver. We will go through them one by one to understand their functions and contributions to our national weather prediction workflow. The first process imports the pandas library to read the data file from the local host, allowing us to describe the dataset. The second process cleans the data by converting the date format to date/time and using ffill to cover any missing values. The cleaned file is then saved to the host. The third process splits the cleaned data into training and test datasets. A linear regression model from the scikit-learn library is trained and used to predict the weather on the test data. A plot of the predictions is created and saved on the host system. With all processes in place, let's add them to Geoweaver one by one and connect them accordingly. Hold the Shift key and drag the mouse from one process to the next to connect the nodes. After connecting the nodes, inspect the code of each process by selecting a node. A side panel will appear with a code editor. With all processes connected correctly, the next step is to save our workflow. Click on the Save icon from the toolbar within Geoweaver. Let's give our workflow a meaningful name and provide a brief description that explains its purpose to allow for more efficient collaboration in the future. Then, select Confirm to save your settings. You'll see the new workflow appear in the left side panel under Workflows. Now let's execute the workflow by selecting the play icon from the Geoweaver toolbar. This action will open a window where you must select the host and environment for the execution. We're keeping the local host, but changing the environment to base, which is managed by Conda. You may choose to use a different environment created by Anaconda or other virtual environment managers on your host machine. Once set, let's click on the Run button. After clicking Run, we input our localhost password and click Confirm to start the execution of the workflow. Upon successful execution, we can check the logs from each process by inspecting them. The first process log shows the data, metadata, and statistics. The second process log confirms the cleaned data was saved. The third process log contains the predicted weather values. We can also view the history of any previously executed workflow records thanks to Geoweaver's automatic history recording feature. In this case, giving us clear and transparent provenance for every prediction. Finally, let's view the plots saved on the local host. Using Geoweaver, we've effectively managed the entire National Weather Prediction project, demonstrating how it can greatly streamline your data science workflows. But Geoweaver doesn't stop at the prototyping phase. Geoweaver seamlessly facilitates the transition from research to operation and allows you and your team to use Geoweaver workflows in a real-world production environment. In this use case, we can utilize a cron job, which will run the Geoweaver workflow at routine intervals and serve up the forecast results to a public-facing website or app. With Geoweaver, the possibilities are truly endless. We can't wait to see how you use Geoweaver to streamline your prototyping and production workflows. For more helpful videos and resources, including how to install and start using Geoweaver, visit geoweaver.dev/guide.